Right now, inside any ant colony on the planet, there's a group of ants doing absolutely nothing. They're not sick. They're not resting because they need to. They simply aren't working, while others around them are hauling food, digging tunnels, and defending the colony non-stop. And here's the detail that flips everything upside down. Researchers have found that anywhere from 20 to 50% of a colony can be sitting idle at any given moment, even when there's real work waiting to be done. In a human company, that would get people fired en masse. In an ant nest, it's the exact opposite. It's one of the reasons the colony survives. And the reason behind it dismantles almost everything we assume about productivity. Let's understand how a colony decides who works and who doesn't, because there's no manager handing out orders. There's no queen ant barking instructions. The queen only lays eggs, she doesn't run anything. What exists is a system called task allocation, studied for decades in labs around the world, and it works in a way that seems too simple to actually function. Each ant reacts to local cues. If she encounters a lot of a specific kind of work in front of her, the probability that she'll take it on goes up. If the work disappears, she stops. There's no planning. There's only reaction. That alone intrigued biologists. But what stayed unexplained for a long time was something else. Why brand new nests have almost no idle ants at all, and why, as the colony ages and grows, the percentage of idle ants keeps rising until it stabilizes at a significant fraction of the group. If idleness were just waste, natural selection should have eliminated it long ago. It didn't. That's a sign that idleness isn't a bug in the system. It's a feature. Computer scientists, trying to mathematically model this behavior, found the answer, and it's counterintuitive enough to stop you mid-sentence. Colonies that maintain a reserve of idle ants respond faster to sudden shifts in demand than colonies where everyone is constantly busy. Picture a sudden flood destroying part of the nest, or a predator attacking out of nowhere. If every ant is already committed to a specific task, the colony takes longer to reallocate labor to the emergency. But if there's an army of available ants with no prior commitment, they absorb the shock almost instantly. Idleness isn't wasted time. It's stored response capacity, waiting to be deployed. That alone would be surprising enough. But there's a second layer to the story, and it takes direct aim at another myth we carry around, the myth of perfect specialization. For decades, biologists assumed, following a logic Adam Smith himself described about human factories in the 18th century, that specialist ants, the ones that always do the same task, should be more efficient than generalist ants. It makes sense in theory. You repeat the same action thousands of times, get good at it, and produce more per unit of effort. Except when researchers actually measured the real efficiency of more than 1,000 workers from the species Temnothorax albipennis, comparing specialists against generalists across different tasks, the correlation simply didn't show up in the data. Ants that did a bit of everything weren't consistently worse than ants that always did the same thing. Specialization helps the colony stay organized. But it doesn't make the individual better at what she does, at least not in the direct way everyone assumed. So what's actually holding this system together, if it's neither perfect specialization nor every individual working non-stop? The answer emerging from the most recent research is uncomfortable for any culture obsessed with productivity. What sustains the colony is structural slack. It's the empty space between the work being done and the total capacity that exists, held in reserve, for the moment it's actually needed. A system where 100% of agents are always working at full capacity is a system with no shock absorber. Any unexpected disruption breaks it. A system with built-in slack absorbs the shock and keeps functioning. Now think about the human parallel nobody likes to say out loud. We live in a culture that treats idle time as a moral failure. A packed calendar is a synonym for importance. A full schedule is a source of pride. And yet, the oldest, most successful biological structures on the planet, ant colonies have existed, without exaggeration, for more than 100 million years. Survive precisely because part of the workforce stays deliberately available, with no fixed task, no prior commitment. This isn't an invitation to do nothing. Idle ants aren't bored, and they're not avoiding work in the human sense of laziness. They're, quite literally, response capacity waiting for a trigger. The difference between that and procrastination is that an ant's idleness is one stimulus away from full action, ready to be activated the second the colony needs it. And maybe that's the question worth carrying with you after this video. In your own routines, in your own life, is there some margin held in reserve for when the unexpected hits, or is every hour of your day already so packed that, the moment everything suddenly changes, there won't be a single reserve left to respond with?